All right, this video is for learning target 5, 6, and 7. It's going to be kind of fast because this recording was not recorded in live in the classroom. I'm recording it during planning, so might move a little fast, so you may have to pause it, rewind, and look at things over. But here's the overview of learning target 5, 6, and 7. Learning target 5 and 6 and 7 are all type of pattern. In arithmetic, it was always an addition pattern, but with geometric, it's a multiplication pattern. So example, if you had 2, 10, 50, 250, etc., the pattern is that we're multiplying times 5 over and over again. Okay, that's called a geometric pattern, and the thing that we're multiplying by, the 5, is called the common ratio. So a geometric sequence is an example like we just looked at there. The R, the common ratio, the R would have been 5 for that example. So just like in learning targets 2, 3, and 4, there was a formula that you could use for various things involving geometric sequences. There's a formula here, a sub n equals a sub 1 times r to the n minus 1, that we'll use in all sorts of ways. The r can always be found by taking any term, that's what the a sub n represents, next to the term a sub n minus 1, it represents any term divided by the one before it. So example, the 250, I could have taken 250 and divided it by 50, and r would have equaled 250 divided by 50 would have equaled 5. All right, so we have 4 examples here. Determine if they are geometric. If they are, identify the common ratio r. So the first one, the pattern is plus 4, plus 4, plus 4, so no, that's actually arithmetic. The second one is times 2, times 2, times 2, so yes, and r is 2. The next one, that's times 4, and then 4 times what makes 9? Well, nothing, so it's definitely not geometric. It's not arithmetic either. It's neither arithmetic nor geometric, but the question was just asking if it is a geometric pattern. And then the last one's kind of weird, so I want to take a second to look at that one. If the fourth pattern is geometric, then it should be true that negative 1 over 25, the last term, divided by the term in front of it, divided by 1/5, should be the same thing as dividing 1/5 by the term in front of it, which would be divided by negative 1. And it's looking good. It would also be the same common ratio as negative 1 divided by the term in front of it, so negative 1 divided by 5. Yeah, every time we got the same thing that's being multiplied, negative 0.2. If you hit math, enter, it'll turn that into a fraction for you, negative 1/5. So that is to say that the pattern is times negative 1/5 times negative 1/5. So yes, it's geometric, and r is negative 1/5. Your brain may tell you, or it may look like it's a division pattern. You're dividing by negative 5, dividing by negative 5, dividing by negative 5, but that is still geometric, and your r is negative 1/5. Now, for the sake of getting used to the formula, we're going to take this pattern and use the geometric sequence formula to find the 5th term. So using this formula, a sub 5 will equal first term 3 times the r2 raised to the exponent 5 minus 1. So that will equal 3 times 2 to the 4th. And you can use your calculator, or 2 to the 4th is 16 times 3 is 48. So briefly, could we have found the 5th term another way? And the answer is, of course, yes, we could have, because they gave us 3, 6, 12, 24. They gave us the first 4 terms, so we could have found the 5th term just by multiplying times 2 and got 48. But those formulas are going to be handy in the future, so we want to take every opportunity we can to practice those and get comfortable with them, even for simple problems. All right, now we move on to learning target 6. I'm going to stop the video at this point and record this as learning target 5, and we'll do 6 as a separate video.